Alright, today we're going to talk about linear inequalities. What is a linear inequality? It will be anything that's a line that's got a less than, greater than, less than or equal to, or greater than or equal to sign instead of the equal sign. Things you want to remember is that an x equals equation is a vertical line, and a y equals the number equation is a horizontal line. So if it's just x equals 3, then it's a vertical line, meaning it's going straight up and down. And if it's a y equals a number, then it's a horizontal line, and it means it's going left and right. So it might say y equals 5 or something like that. Another reminder that you want to remember is that if you divide by a negative, you have to remember to flip the greater than or less than sign. So what we're going to be doing is we're going to graph the line. You've got two options. You can put it into slope-intercept form, or you can use standard form and find the x and y intercepts. After you graph the line, you're going to figure out which kind of line you need to use. It's important that you know that you use a solid line on a less than or equal to or greater than or equal to, and you use a dotted line if it's just greater than or less than. So notice the equals, the two signs are not there. Then what you're going to do is you're going to shade appropriately. One way to do that is to pick a point on either side of the line and plug it into the equality. If the inequality is true, then you shade that side. If the inequality is false, then you shade the other side. Well, here's what I really like to do. I like to think about it this way. If it's a greater than, shade above the line. If it's less than, shade below the line. Those are the two things I like to do. So on this problem, what we'll do is we'll go ahead and graph this. And this is in y equals, this is slope-intercept form, y equals mx plus b. It just says y is greater than, and this would be your mx plus your b. So my m is 3 and my b is negative 1. So I'll write that. My m is 3, and I'll denote that as 3 over 1. And my b is negative 1. Remember, we're always graphing the b part first, so we're going to graph negative 1. And then we're going to climb 3, rise 3, and run 1. Remember, we can do that as many times as we want. I'll do it a few times, and then I'll also go the other direction. Negative 3 over to the left 1. Negative 3 over to the left 1. Then once I have my line noted by the dots, I'll figure out which sign I need to use. This is a dotted line because it doesn't have the equal to sign underneath it, so I will mark it as a dotted line. And then I'm going to talk about shading. Which side do I shade? And like I said, you can pick a point. So let's say you pick 3 or negative 3, 1. Negative 3, 1. Well, if you plug that in up there, I'll just rewrite the original. I can plug in negative 3, and I can plug in 1. I get negative 9 minus 1, and I have 1 is greater than, that would be negative 10. So this is true, meaning I would shade this direction. I just like to say, well, it's a greater than sign. Okay, so as long as your y is on the left-hand side, you can say, well, it says y is greater than, so it means you'd shade above the line here. This is definitely above the line. This is below the line. Let's see if I can squeeze one more in here. So I've got m equals 1/2, and I've got my b is 1. I'll plot my 1, and then I'll rise 1, run 2, rise 1, run 2, rise 1, run 2. Do that a few times, or down 1 to the left 2, down 1 to the left 2. I need a solid line because this is greater than or equal to. This is a solid line. Connect all the dots using a solid line. And then I'm looking at this, and it's a greater than sign, so it means I'm going to shade above the line. This is above the line, so all of these are solutions to that inequality. Again, you could pick x and y intercepts, or you can just solve for y. I'm going to go ahead and solve for y. That's my favorite thing to do. The x and y intercepts are easy to find on these. On this particular problem, you do get two whole numbers. You get x is 4 and y is 6. So we can actually make sure that we have graphed this correctly. I just like to do it this way because then I can check out the sign. As long as this y isn't negative, the sign isn't going to flip. So you could look at that. We're going to go up to the 6. This has a negative slope, and notice how I said that the y-intercept would be 6 and the x-intercept would be 4. So we'll go down 3, over 2, down 3, over 2. There's where the y-intercept is 4. I use a dotted line, and then this says shade below the graph, because it's less than, so I'll shade below the graph, and that would be the solution of this linear inequality, anything that's below that line. This last one that I'm going to graph, I'm going to change the sign to plus the opposite. This is where the sign's going to change, so I would have to think about flipping the sign around when I'm solving for the y, or if I was just going to use x and y intercepts, then I'd have to remember that it actually was shaded the other direction. So negative x plus negative 4, divide by negative 2, divide by negative 2, divide by negative 2. This really says I have a negative 1 over a negative 2, which is a positive 1/2. And then a negative 4 over negative 2 is actually a positive 2. So I have a positive 2. I'm going to go up 1 over 2, up 1 over 2, or down 1 to the left 2, down 1 to the left 2. I use a solid line, and it says greater than, so I would be shading above the line for my solution. Oh, I made a mistake. Let me erase that. What did I forget to do? I forgot to flip my sign because I was dividing by negative on both sides. So actually, I should be shading below the line. So by checking those points, you can actually find your mistake, okay, as well, rather than relying completely on remembering to flip the sign. Okay, writing inequality for the given graph. This given graph is a line. So I know it's going to be y. And what I'm going to do is I'm going to pick out, I'm going to say, well, it's shaded below the line, so I know it's less than. It has a solid line, so I know it's less than or equal to. It goes through at negative 2, so I know my b is negative 2. And it rises 1, 2, 3, and it runs 1. So it goes up 3 and runs 1. So that means my slope is 3 over 1. And I'll put my x and I'll put plus. So really what I can state this to be is just 3x minus 2. The last example is an auxiliary problem form. What we're going to do is we're going to write an inequality to describe the situation. So Billy Bob wants to have a cookout with hamburgers and brats. I'm going to call my hamburgers my x and my brats my y. It doesn't matter which one's which. Hamburgers are $3 a pound. So for every pound of hamburger I buy, it costs $3. And so I'll be adding on some money, $2 a pound for each brat. So 2y. And he has at most $30. What that means is I can't spend over $30. This number has to be the bigger number. I can't spend $40 because he doesn't have $40 to spend. So this one has to be the bigger number. It could be less than or equal to. So this side, the amount of money I spend can be less than $30 or equal to $30, but not more. What I'm going to do is I'm going to take this inequality, 3x plus 2y is less than or equal to 30. I'm going to plot it on a graph so you can see the different situations that can happen. So I have a negative 3x. I will get a 2y is less than or equal to negative 3x plus 30. Divide by 2, divide by 2, divide by 2. I get y is less than or equal to negative 3/2 x plus 15. I'm going to plot 15, but I've got to have my graph made. So I'm just going to count by ones here. And 15 happens to be right here. So this is my y-axis, and then this is my x. I'm going to go down 3 over 2, down 3. 1, 2, 3 over 2, down 3, over 2, down 3, over 2, down 3, over 2. So over here, my x values, and I would use a solid line, and I would shade below the line. The only thing else I want to mention about this problem, and then this will be the end of that lecture, is I want to mention that what this really means. If I go back to this, the hamburgers were the x and the brats were the y. So I'm going to go ahead and label this as the hamburgers being the x and the brats being the y. let me interpret this for you. What this means is that I could buy 4 pounds of hamburger only. I could buy 4 pounds of hamburgers and 3 pounds of brats. I could buy 6 pounds of hamburgers and 6 pounds of brats. All of those would be solutions. This one would be something where I'd spend exactly $30, so anywhere on the line would be exactly $30. Anything below the line would be less than $30 that I'd spent, but still a possibility for the amount of hamburgers or brats that I would buy. So hopefully you understand this, the solution a little bit better and how you could interpret that.